Students, hello. Can you hear me? Yeah. Is everything clear to you? Fine. Okay, fine. Inshallah, today we will discuss sets and maps. Bismillah. Yeah. Can you see the screen now? Is the screen clear? Okay. Fine. I think both the screen and the sounds are clear. Okay. Let me put the recording on here so that it will be helpful for you later. Okay, this is M251, M257, such maps. Okay, students, everything clear to you? Sound on the screen? Yeah. Okay. So we'll start today, inshallah. Today we are going to talk about sets and maps. So we'll talk on the sets and how we use these sets. What are the benefits of using the sets and maps? These are all from the collection classes, or you can consider these as the collection classes that can hold a number of values or a set of objects or a set of values. Fine. So today's objective of this meeting is to store sorted, unordered, and non-duplicated elements using a set. So here we need to talk about set. What is a set and how to use the sets and how we can store the elements in a set. Fine. Different type of sets we can create. We'll also explore how and when to use hash set, linked set, and tree sets. So there are different sets here we have hash set, we have linked hash set, tree set. We'll see what are these and how to use these sets, okay, in our programs. And we'll also compare the performance of sets and the list, because we have talked about list before, that is an array list, which is also under collections. So we'll talk about the comparison or the performance of both sets and the list. And the objective is also tell the difference between the collection maps and describe when and how to use the hash map, linked hash map, tree map, and store the value associated with the keys. So we'll talk about maps also. Map is also under collections, which can store a set of values or a set of objects, but it has two things, one key and the value. So we will discuss inshallah what is a map, how to use a map, what are the different maps we have. Like we have in the set, we have hash set, we have linked hash set, and then we have tree set. Similarly, in the map also we have hash map, linked hash map, and the tree map. Fine. So we'll see that how to use them. Okay, what are their constructors, different methods they have. Okay, fine. So we'll start. These are the objectives of today's meeting. Motivation to this topic is that, for example, in US there is something called no-fly list. Okay, which is created to maintain the terrorist screening center, where people are checked when they travel between the different states in the United States or travel out of the United States. Okay, so if you want to keep a list of names, so we can use a set there to store a list of names. Fine. Which is considered as a no-fly list. Okay, where we store all the names which are not allowed to travel outside the United States or between the commercially between the states. Fine. So suppose that we also need to store some more detailed information about the terrorists or about the person under no-fly list. We can also use the maps there. Okay, a maps can store a name and along with it some other values or some other data. Fine. So we can use maps, we can use sets. So what we get here, idea is that sets can be used to store a set of values or a set of objects, and maps can also be used to store a set of values, but map can store more information than set. Okay. So in general, if you look into collection framework, was what you see on the screen, the collection framework. A collection has the sets, lists, and the queues. Fine. We discussed something about the list before, like array list we have seen. Fine. So we'll talk about inshallah on sets, and we also talk about on maps. Okay, inshallah. The collection framework, this unifies the collection classes, which contains two root interfaces, that is called collection and maps. These are interfaces. Fine. These are root interfaces, and under this all other sets and maps comes. Okay. Subset, list, and queue are the sub interfaces of the collection framework. Set, list, and queue. Arrays are not a part of the collections. Fine, we have seen that before also when we were discussing array list. We saw that arrays are not part of the collection framework. Fine. So we have the sets here under the collections. Fine. Now you can see that the hierarchy here, the interfaces what we have here is the collection interface, which is the root interface we have. Then we have the set, list, and the queue are the interfaces under the collection interface. Okay, with different implementations. I mean, not implementation. I mean, with different designs, because the interfaces, sorry, will not have the implementation, of course. Fine. So these are under designs. Excuse me. And we also have some abstract classes under these interfaces, as you can see, or the abstract classes. And here comes the concrete classes that we can use. We can implement or we can extend in our classes. Fine, or we can import. Sorry. We have a tree set. We have a hash set under which we have linked hash set. We have a stack under vector. We have array list. We used to use this array list before. We have linked list and priority queues and all. Fine. So now in this meeting we are talking about the sets, which are these. Okay. which is under abstract set, which is under abstract collection in abstract class, which comes under the collection set interfaces, okay, which implements them. So we'll talk about today, inshallah, the sets which is over there. The collection interface is the root interface for all collection objects, that is for sets, list, and the queues. The collection framework does the three things, which is it specifies a set of collection interfaces, recommends some constructors for the classes to implement them, and provides some utility classes, some helpful classes. Okay. An interface, as we have studied, an interface is a list of methods without implementation. So of course, here we are not going to use an interface, but we are going to use its concrete classes. Okay. Walaikum assalam, Sharif. So we are going to use its concrete classes that implements the interfaces. Fine. So here we are looking into any concrete class that implements the interface under this collection interface. Okay. So collection interface is a super interface for all the collection interfaces like sets, lists, and queues. If you want to use these collection interfaces, we need to import this java.util.star. Fine. Any collection, if you want to use, you need to import java.util.star. So here is a collection interface, and it's some of its methods we have under the collection interface. You can see those methods like add all, clear, contains all, right? Different methods with that description. Like for example, add. If you want to add a particular object to the collection, or let's say to the set, we can use this add method. If we want to add a set of values, I mean a collection to an to a new collection, fine, a set of elements, then there you can use add all. We have a clear, to remove all the elements from the collection and make it empty. Okay. And contains an object to check whether a particular object is in the set or in the collection or not. It returns true or false, of course. Contains all will check whether a particular set of elements or a set of objects are in the collection or not. We have an equals to check that the collection is equal to another collection. Hash code that returns the hash code of the collection, which is an integer value. Is empty to check whether a collection is empty or not. Remove all, retain all. Retain all retains all the element that is in the collection C, and in this the invoking collection. Okay, that is like an intersection. The common elements between two collections will be retained by calling this retain all. Size, of course, returns the number of elements. To array will convert this collection into an array of objects. Fine. We also have an interface called iterable, okay, which is has an interface called iterator. Now this iterator interface is used to iterate or to go through the set element by element. Okay, so there we use this iterator interface. Okay, so iterator interface basically is it allows to go through the collections or to go through the set of elements. Like for example, to go through the sets or array list. Fine. It has methods like has next that returns true if there is more elements to read in the collection. Next will return the next element in the collection. Void remove will remove the current element from the collection and will move to the next element. Okay. We can use this iterator interface, whenever we want to iterate through the collection of values or a set of values. And for example, here you see that we have a list of strings. And if you want to go through the list of strings, you need to specify what type of iterator you want. We want a string iterator because we want to go through the set of values which are strings. Okay, so we call that x.iterator, and we'll check has next. If there is a next element to read, we call the next. This will read the element and go to the next element till it has all the elements. I mean, till it reads all the elements. Fine. So so here iterator here can be used here to traverse through the set of elements or through the collection of elements, whether it is an array list or it is a set or it is a map. Now some of the collection interface methods that what we have seen here before, these are described here again, fine, with their categories and with their descriptions. We'll look into this. For example, boolean add an element type object. This is an adding method which will add an element or an object to the collection, and it returns true if the element is added and false otherwise. If the element is not added for any reason, this method will return you false. So that means that while adding, you can check whether it is whether this is added or not by its returning value. So if this is returning true, that means that the element is added. And if it is returning false, which means that the element is not added. We also have add all method. Like suppose if you want to add a set of values, fine, or a set of elements to the collection. So there you can easily add it by calling this add all collection. Excuse me. So we can use this add all to add a set of elements. Of course, this also returns a boolean value, true or false. Fine. So it returns true when the collection or a set of values is added to the collection, and false if not added. Fine. Remove an object will remove a particular object from the collection if it exists. Fine. And it returns a true if it is the element is or the object is removed. And if it is not removed, for in case like the object is not in the collection and hence it is not removed, it returns you false. Fine. That returns you false. We have a clear by default. It says like remove all the elements in the collection if there are any elements, and it is void. It does not return anything for you. It simply remove all the elements from the collection. Size, of course, it returns you the size of the collection. That is the number of elements in the collection. That is how many elements there in the collection. And we have contents to check whether a particular object is in the collection or not. Fine, of course, this is just to test like whether a particular object is in the list. It returns true or false. And then we have is empty to test whether the list is empty or a set is empty or not. It does not have any element. It returns true or false. If the list is or a set is empty, it returns true. Otherwise, it returns false. So these are some useful methods from the collection interface that we can use when we are using sets. Okay. So when we are using sets, we can use these methods, fine, in our program for different purpose. Okay, now let's look into the set interface. Till now what we discussed is the collection interface. Now set interface comes under the collection interface. Okay, it is a sub interface. Okay, so a set is not ordered collection in which the elements is unique, that is there are no duplicates. Duplicate elements are not allowed. A set can grow and shrink as the elements are added or removed, hence it is dynamic in size. The contents of set are not indexed, so there is no way that you can go through the index like an array. You go through the index. No, you cannot go by index there. Fine. So the most general kind of set is an unordered, although we see there are some ordered sets also. There are some ordered sets, but the most general is that unordered set. Fine. So you can just see a set as a pool of objects. I mean, a set where there is a list of objects, then none of them appear twice. It means that what? There is no duplicates. There is no duplicates. And we can add and remove the things to the pool. Like we can add the elements to the set and we can remove the elements from the set. Usually by using these methods, what we discussed before, using these methods, we can simply add an elements, we can remove the elements, we can clear all the sets. We can check whether a particular element is in the set or not. Right? So that is possible through the sets. So set is again an interface. It's not in concrete class. It's not in concrete class. This is a sub interface of the collection interface. So collection is the main interface. Under the collection, we have this set interface. And the main thing here is that it is not an ordered collection. That means you don't see that the elements are in order. Okay, and there is no duplicates, which means that there are no duplicate elements will be added to the set. If you try to add a duplicate element, that will be removed automatically, and only one element will retain in the set. And it is in dynamic in size, which means that as you add the element, the size will grow. Fine. There is no fixed size for the set. Fine. The set interface extends the collection interface because it comes under the collection interface. It does not introduce any new methods or constant, but it simply uses the methods of the collection interface. What are those methods? These are those methods which we have here. Okay, these methods are used simply. Okay. The concrete class that implements the set, like tree set, hash set, okay, must ensure that there is no duplicate elements can be added to the set. So that is no two elements such that E1 and E2 are equal by this. That means no two elements are equal. Fine. Their contents are not equal. Fine. So here comes the set hierarchy, the set interface hierarchy. As I told, set is an sub interface for collection interface. As you can see on the screen, we have the set interface, which is under the collection interface, and of course it has some abstract classes. Fine. And the concrete classes we have, like the hash set, we have linked hash set. Fine. And we have tree set. These are the concrete classes that we can use in our programs. I mean, we can create an object of them to store a collection of values, right? Hash set, linked hash set, and tree set under the set interface, which are implementing the set interface. Fine. So this is the hierarchy of the set interface. Now let's look into creating a set. As we know that set is an interface, so we cannot create an object of set, but we can give we cannot give the reference. Fine, we can declare an object of it. Fine. What we have to use is the concrete classes of this set. So what are the concrete classes here? We have, of course, we have here the hash set, we have linked hash set, and we have the tree set. From these three, we can use any one of these three concrete classes to create a set in our programs. Fine. Okay. So whenever we want to create, a collection, Fine. So first of all, decide on the interface type. What type of interface you want to use. You want to use a set, or you want to use a map, or you want to use the list. What type of interface you want to use it when we want to create a collection of values. I mean, create collection. Fine. So decide on the interface type. So let's say, for example, we want to use the set interface. Choose the implementation class under this interface. If you are choosing the set interface, under the set interface, we have seen like there are three classes, right? So choose any one of these three. Choose any one of these three. Fine. So for example, here, let's say that we use the implementation class hasSet. Fine. Declare an element type. What data type will the connection will contain, whether it is an integer values or a string values or any other objects. Fine. Doubles or any other objects. Fine. So these are the three things we must do first when we want to create a collection object which can store a collection of or a set of elements. Right. First step, to decide the interface type, what type of interface you want to use, whether you want to use an interface or set interface or a list or a map. Okay, what type of interface you want to use, and what is the implementation class you want to use, because under every interface there is an implementation classes. So what interface type, what implementation class you want to use, and what type of elements do you want to have inside the collection. I mean, you want to have a set of strings, you want to have a set of integers, you want to have a set of objects, you want to have a set of doubles, what type of, elements you want to have inside the set. Fine, you can declare a set, an object of set by specifying the element type. Fine, and create it by either by using hasSet. Fine. HashSet does not maintain any kind of order of its element. It is an unordered elements. Fine. Tree set will sort the elements in ascending order, and linked HashSet will keep the order of insertion. It is like linked list, right? You have studied the linked list. So linked list what will keep the order of insertion. Fine. So linked HashSet will also keep the order of insertion. First element, second element, third element, fourth element, like this. It will keep the order of insertion. But hasSet does not keep any order. It is the most general form. Of course, no duplicates, but at the same time, it is not maintain the order, alphabetical order or ascending order, descending order. Not any order is maintained under the hasSet. But if you want to maintain the order in ascending order, you can use a tree set. Right? And if you want to maintain the order of insertion, you insert the first element, then insert the second element, then third element, and you want the elements to be in the same order, then we can use the linked hasSet. Fine. So declaration is simply you declare it an interface type set, the type of elements you want under the set, fine, and the name of the set object. And creation is of course by using its implementation class. HubSet is equal to new hasSet of strings. HasSet is an implemented class under the set interface. Okay, so this way we can simply create it. Let's try to create it. I have installed the NetBeans just now. Let's see if it is installed quickly. Yeah. Fine. So we'll try to, inshallah, create a set interface here. A set object here, which we can store a set of values. As you can see on the screen, there are different ways like we can create it. There are different ways we can create it. Uh, you can see here set of type strings. Set 1 is equal to new hash set of type of strings. Fine. Now this is a default constructor for hash set, where set 1 will be the hash set, fine, with an empty hash set, and does not specify the size. What is the size, initial size or the capacity of the set? It is system dependent. The JVM will decide what is the size or what is the capacity of the set. Or if you don't want to use an set interface, you can directly use the implementation class like this. Both are same. This one or this one, both are same. Okay. At the end, you are creating an hash set object, because hash set is the implemented class for the set. If you want to specify the capacity, the initial capacity, we can use this one where we specify the initial capacity here. Right. And if you want to create a new set from an existing set, we can do it something like this. From an existing set. Right. And if you want to put the set in order, in ascending order, simply create a tree set. A tree set, because tree set, as we said before, tree set is will keep the elements in ascending order. The tree set will keep the elements in ascending order. Fine. So if you want to create a set here, it's very simple. Let me create a new project here. M251 underscore meeting 12. Or sets set maps. So what is the import that we need to do for to use the sets? Students online, what is import that we need to do for to use the sets? Yes. Students online, can you hear me? Yeah, what is the import statement that I need to use the sets and maps? Import what? Util. Yeah, that's very good. So I need to use import java.util.star. I can use the sets here, right? So we create set of string. Set 1 is equal to new hash set of strings. Fine. With this way, we have created the set 1. Now set 1 is a hash set, fine, where we can add the elements of type string. So here it defines the type, what type of elements you can add to the set. Okay. So this defines, like, we can also create, the capacity, initial capacity of the set if you want to set the initial capacity also. Okay. Hash set is a concrete class that implements the set, and of course the hash set does not keep the elements in order. Fine. We can create hash sets simply by specifying the capacity or just by mentioning the set. If you want to create from another set or just by capacity or by default, we can create a hash set. Fine. Sorted set is a sub-interface of set which guarantees the elements are under sorted. So if you want to create any set which keeps the element in sorted order, we can create it by using tree set. So how to create that by using tree set is very simple. That create set of strings set2 is equal to new tree set of strings from the set1. So from the set1, what does it happens is whatever you add in the set1, that is in unordered format. Fine. The set2 is a tree set which will make the elements in sorted order. It means you keep the elements in ascending order. Fine. Linked hash set, of course, what I told you before, I mean what I said before is that the linked hash set will keep the element its insertion order, like how you insert the elements. The order of the insertion is kept under the linked hash set. Right. So linked hash set is again the same way what we created by using tree set and the hash set. The same fashion you can create the linked hash set. Okay. Some of the methods specified the set interface, of course, because it comes under the collection framework. It also has all the methods which are under the collection, what we have seen before, right? What we have seen before. It has size to check how many elements are there in the set. It has add method to add an element to the set. It has isEmpty to check whether the set is empty or not. It has contains to check whether a particular object is in the set or not, that returns true or false. It has an remove to remove a particular object and returns true if the element object is removed, otherwise it returns false. Okay. So if you want to check the size of this, for example, initially the size, what is the size? The size is 0, right? So let's say for example system.out.println set1 dot size. Fine. So of course the output what you get is 0 because we don't have any element in the set, so hence it returns the 0. Fine. So you can see that the answer here is, or the output here is 0. Fine. Okay. Now iterating over a set, I mean going through the elements of the set, whether we can do it by two ways. One is by using the for each statement, the other is by using the iterator, interface. Fine. We talked about before iterator interface, which has methods like has, next. Fine. So these methods can be used, with the iterator interface to iterate through the elements one by one. Or we can use a for each statement, like we use for each statement in the array list for the list collection. Similarly, we can use for the set collection also. Okay. Fine. Let's say that, for example, we have the following set of strings, and we add these elements. Fine. Set.add London, Paris, New York. So let us add it here also. Set1 dot add of London, set1 dot add of Paris, set1 dot add of New York, set1 dot add of New Jersey. Fine. So here I have added some 4 elements. Fine. Some 4 elements. Okay. Now let's print this set simply by using print system dot system dot out dot println of set1. Okay. Now simply I am printing the set1. Yeah, set1. And let's see the output here. So you see that the set1 is printed. Okay, 4 elements, and the size is 4 here, because here we are printing the size, right? So that's a 4 here, the size. Okay, so I'll just add a statement here, size equals set1 dot size. Fine. Now let's try to add a duplicate element, set1 dot add of Paris. Now what I am doing is I am trying to add a duplicate element, and we said, like we have seen in our previous slide, that set does not take the duplicate elements, right? It does not take a duplicate elements. Okay. Now let's see whether Paris is added 2 times or not. Fine. Now you see that Paris exists only one time. Paris exists only one time. So what does it mean? It means the set will not take the duplicate elements. Okay. And now we see the order of adding. First we add London, then Paris, then New York, then New Jersey, then Paris. Fine. Then we see that it is not in that order, like what the order is. That means that it is an unordered set. It is an unordered set elements. So this is one way that we can directly print the set, which is directly we can print the set. Now the other way is that we can print the by using a for each statement. We can print the set by using this for each statement. For each. Okay. So we use this for each statements here. Instead of directly printing it, we can use this for each statement for string x to the set1. Okay, system dot out dot println x dot to uppercase. I'm printing the elements in uppercase. Okay, just to print the elements in uppercase. Fine. So one way is that we print it like this. The other way is like we are printing element by element by using for each. By using for each loop. Okay. Now let us run and see. So you see that we print the same elements here: London, New York, Paris, New Jersey, by using for each loop. So both the way you can use. By that directly you can print the set, which will be in a form of set, which you see this one. Okay, or you can go element by element by using for each loop. Fine. Or you can also go through the iterator by using the iterator interface. Okay, by using the iterator interface. Okay. Now how to use that iterator interface, we have seen it before here. I'll show you that. The iterator interface. Yeah, here. Fine. You need to create a string iterator. Okay. So we call the iterator function and you use the has next. Has next. Fine. So here comes the set1 for you. And use this set has next. And you print the next element by using the iterator. Fine. So either we can use iterator Whether we can use a for each loop or we can directly print the element. Fine. هذه مراجعة للمترم ولا لا؟ هذا ليس مراجعة للمترم، هذا ال sets and maps meeting 11. fine. على فكرة إنه there is no midterm exam، يعني ما في midterm exam، في واجبات ممكن تيجي واجب ثاني كمان. fine. there is no midterm exam here. okay. Inshallah. Let's look into this exercise 1. Write a Java code to do the following. Create a set of a string with each element being the name of the herb. Add the following herbs and print out the size of the set and print the set. Abdurrahman, بالنسبة the other homework, it is not yet clear. It is that it will be only 24 hours. Let's wait for the instruction from the deanship, because it can be like take-home assessment, or it can be any other type of homework. So might be 24 hours or more than 24 hours. So you don't need to worry about that. It will be like an easy question, inshallah. And it will be an easy homework. Right? So we don't know exactly whether it is 24 hours or it is 8 days or 7 days or 2 days. Still, the instructions from the deanship is not arrived for us. And I think even it is not published in the university websites, not in the LMS also. So we need to wait. It is all under discussion matters. The discussion is going on still in the university. Once the university finalize the things, they will put everything on their sources valid on their university website and university LMS. And we'll inform you also as a tutor and as a BCC. The BCC will inform you by email also. Okay. So don't worry about that. Just prepare the course for your final exam as well as for your homework. I think you all did the homework. Okay. So do your homework best. Prepare your work for, get ready for your final exams also. In between, you will get another homework. You can simply solve it and submit it. Okay. So don't need to worry about that much. Okay. Now exercise 1 here, write a Java code. Coming back to the course, coming back to the discussion. The exercise 1 here, it says write a Java code to create a set. Okay, with a name called herb. Add these elements: rosemary, parsley, chamomile, and rosemary again. Fine. And print out the size of the set and print the set. This is the same thing what we did here. We add the city names. We create a set of strings. Add the city names. Fine, and print the set and print the size of the set. Right? We print the size of the set. You have to do the same here for this. Okay, so we're creating a hash set here. Okay, add rosemary, parsley, chamomile, and rosemary again. Size. What will be the size here? Yes, students, what will be the size? Three, 4, 3, how come? So what will be the size, 3 or 4? Now the one who says 3, Badrija, why it is 3? Can you explain it? Zero, 1, 2, 3. It means 4 elements. The size will be 4? No. Cause Rosemary is twice. Yes, very good. We see that sets are not does not hold the duplicate elements, right? So Rosemary here twice will be counted only once. Fine. Firstly 1 and Chamomile 1. So the set size is 3. The size is 3, not 4. Why? Because here there is an element, duplicate element, and duplicate element is not added in the set. So here the size is 3. We can also see in our program what we did here in our program. We add how many elements here? London, Paris, New York, New Jersey, Paris, 5 times, right? But the size it is giving us 4. Why? Because here the Paris is added 2 times. So which it removes the of course the what you call the duplicate elements. Fine. The Paris is twice here. So similarly here also the size is 4. Okay. So that's about this set class. Fine. The next type of set here we have tree set. Tree set, of course, it is an ordered set of elements. It is not an unordered like hash set. Hash set is an unordered. If you want to put them in order, in ascending order, we can use tree set. We can use tree set. That where we want to put the elements in ascending order. So all what we need to do is that we need to create a object of tree set. Fine. That the elements will be automatically in order. The elements will be automatically in order. So for example, here we see the elements are not in order here when we print the set. When I print the set here, what I have the elements is not in order. Okay. Now let me print the set 2. I mean set 2 here is what? Tree set. Set 2 is tree set. Tree set is the elements of the tree set will be in order. Fine. So if I print the set 2 here before the size system dot out dot println of set 2. Fine. So let's see the elements in set 2. London, New Jersey, New York, Paris. Now you see that the elements are in order in set 2 because set 2 is what? Set 2 is a tree set, and a tree set put the elements in ascending order. Fine. So here the tree set, using a tree set, we can put the elements in ascending order. There is a case study program here. Count the keywords in a particular Java file. Right. This is interesting program, and I leave you this program on you to do it because it's an interesting and it is a good learning program. Fine. You can simply click on this and get the program. Okay. So this program asks you to enter the file name, and in that file it will count how many keywords, how many Java keywords are there, and this is by using the sets and the files. Okay, you can see this program here, the main method here. It asks you to enter the Java source file and create a file object. If it exists, it calls count keyword method. Otherwise, it's a file does not exist. Now it calls count keywords method. In this count keywords method, you can see that we are storing a set of keywords, all keywords of Java. not all, in some of the keywords of Java, and trying to look that how many keywords are there in a Java file. Fine. So we create a set out of it, and hash set. Okay, and we look into that. We put in the file. We read the file. Has next. We read the next element and check whether the set has that word or not. If it has a word, it will make an count. Fine. So every word by word it will check, go in the file and check, compare it with this set by using the contains method. It returns true, then it will count, increment the count. Finally, it returns the count, the number of keywords that the Java file has will be returned here. All these keywords counted from this. Okay, so nice program. You can try this back. Fine. Bulk operations on set. We can do some bulk operations on the sets. Fine. Like for example, add all, contains all, retains all, remove all. So we are doing, we are using a collection of values, to do an operation or to call a method on sets. Fine. The contains all method first. It returns true if set 1 has all the elements which are in set 2. Fine. So we can check, like for example, in our program here, we have set 1 and set 2, right? Set 1 and set 2 both are having the same elements. Fine. So we can print, like for example, true or false here. System.out.println set1 dot contains all of set 2. This returns true or false. Okay, so we'll see true or false in the output screen. So it says true. It means that both the elements, set 1 has all the elements which are in set 2. Set 1 has all the elements which are in set 2. Similarly, we have add all. Add all, it means that add the all elements of set 2 into the set 1. So it is like a union operation, union of algebra. If you remember algebra, union, it means a common, all the elements of set 1 and set 2. Removing the duplicates. If there is any duplicate elements, that will be removed, of course. Okay. So this one. Retain all. Retain all is like intersection, common elements between set 1 and set 2. What are the common elements between set 1 and set 2 will retain. Okay. If there is no common element, will be take out, will not be there. Remove all is set 1 minus set 2. If you recall the set operation in algebra, this remove all the elements of set 1 which are in set 2. So it is like a set difference. Fine. So if you want to do union, intersection and difference, you can use this add all, retain all, remove all. Add all, retain all and remove all. Okay. So sometimes in the exam, and I remember that somewhere in the final exam, it has been asked before to do these operations using set. To do the union and to do the intersection and to do the difference, what are the methods used? Fine. So you can take this as an important, and you can put some program on this. Fine. Okay, bulk operations on the interface. These operations which will change the original set, we call it as an destructive operations. Destructive operations. So here, operations that alter the contents of the receiver are referred to destructive operations, whereas those that does not refer to that does not change the contents of the receiver, we call it as a non-destructive operations. The bulk operations, which are retain, add, and remove, correspond to the set operations, which is called intersection, union, and difference. Okay, these methods are destructive methods because it will change the original set. Fine. So whenever we want to work with these operations, with these destructive operations, it is better like you make a copy of the set and you apply on the copy, because we don't want to lose the original set if there is anything wrong. So if you want to apply these destructive operations on the sets, it is always better that to use the you make a copy of the set first and you apply these methods on copy, not on the original set. Okay. Now let's look into this exercise number 2. It says create two linked hash sets 3, 4, 5, 2, 1 and 2, 3, 7, 8, 9. Find and print their union. Union, it means what? Add all. Intersection, which is retain all. Difference, which is remove all. Union, add all. Union, it means add all. Intersection, retain all. Difference, remove all. Fine. So find and print their union, intersection, and difference. You need to print the original set first. So it means that you make a copy of the original set, and on the copy you apply this add all, retain all, remove all. So we need to create two sets here. Two sets. Okay. A linked hash sets. As in the question, it says like to create a linked hash sets. Fine. So here is the program. First, what we are doing is we are creating an integer array to store these elements. Okay, and converting this into the list and converting those lists into the sets. Fine. Or what you can do is you create directly a set and use add method. S1 dot add of 3, S1 dot add of 4, S1 dot add of 5. Fine. You can use that add here. Simply, instead of these 4 lines, what you can do is you can create these two and then you can call S1 dot add of 3 and then S1 dot add of 4, like this. Okay. Or you can directly go to these 4 lines and do this. Fine. Okay. You'll have a look into this program, and we'll take just a 5 minutes break, not 5 minutes, inshallah, to 2 minutes break, and we'll come back inshallah after 2 minutes. Inshallah, I will have some water and come back. Okay, and after we come back, inshallah, we'll do this program. Okay. Okay, welcome back. So let's do this program where we want to add these elements to the hash set. Okay, these elements to the linked hash set 3, 4, 5, 2, 1, and these elements to another hash set, and we want to do these operations like difference, union, and intersection. Okay, so let's put this here in the NetBeans. Which we take out all this. Okay, we'll create an integer array first. Integer array A1 is equal to, we'll put the elements which are in order 3, 4, 5, 2, 1. Okay, and we create another integer here, integer array A2 is equal to, we'll put the elements like 2, 3, 7, 8, 9. Okay, and we create the lists now. List of integers. List of integer L1 is equal to new array list. Array list of integer of arrays dot as list A1. So this will convert the list, convert this integer array to the list L1. Fine. Similarly, we do it for another, we create another list L2 for the second array, that is A2. Now from this list, we create a set of what? Integers. Int integer 1 is equal to new linked hash set. Okay, linked hash set of integer of the list 1. Now linked hash set, as we saw before, this will keep the order of insertion of the elements. Okay, we create another hash set for the second list. We say it is set 2, and for the list 2. So we got two sets here. Now the next thing is that we need to do a union, intersection, and difference, fine, between these two sets. So what we call that is that set 1 dot union of set 2, or for the union, let's say for example add all of set 2, but set 1 will change. Fine. So what we will do here is that we create the duplicates of set 1. We create the duplicates of set 1 as union, intersection, and difference. Okay, so it is S1. For the S1 we create U, or let's say union. This is union set. Okay, similarly if we want to create the set 1 that is intersection, so instead of union it is intersection. And similarly we will create difference. So three sets that makes the copy, of set 1. Okay, now we will print set 1 and set 2. System.out.println. What is set 1? Set 1 is what? Plus S1. Okay, and system.out.println println of set2. So what is set2? S2. Okay. Now after this, we'll call the difference, or let's say union. Union is what? Add all. Union is what? Add all. So union dot add all of S2, because union is what? Set1, copy of set1. Set1 dot add all of set2. This will give you the union. So I'll print the union system dot out dot println of S1 union S2. S1 union S2 is what? It is union. Yes, it is union. Okay, very good. And now we did the union, and now let's do the intersection. Intersection dot remove all. Intersection is what? Retain all. Retain all of S2. Okay. So we'll do system dot out dot println S1 intersection S2 is intersection. We did the intersection. We use plus here. Now difference. Okay. Difference dot remove all of S2. This is difference. Okay. System dot out dot println of S1 difference S2 is plus difference. Okay, so this is our program. Now let's run this and see the union, intersection, and difference. Set 1 is 3, 4, 5, 2, 1, and set 2 is 2, 3, 7, 8, 1, 7, 8, 9. It is in the order which we inserted, okay, because it is a linked hash set. S1 union S2, common elements in set 1 and set 2. 3, 4, 5, sorry, all the elements from set 1 and set 2, and common elements are taken only once. Okay, so 3, 4, 5, 2, 1, 7, 8, 9. This is union. Intersection, what is the common between these two? We have 2 and 3 common. Okay, and difference, what is there in 1, okay, which is not into, yeah, S1 minus S2, fine. So it is the difference. Okay, so this way you can do this program. So I remember, like as I told, there was a question in the final exam on this, you know. I don't know with last semester or before, but I remember this type of question in the exam, in the final exam. Okay, so that's all about the sets. That's all about the sets. So do you have any questions on set before we move to the map interface? Any other student has any question on the sets? Anyone has any question on set? No questions? Great. Okay. Now we'll talk about map interface. A map interface is store a pair of linked items, key value pairs. Key value pairs known as entries. It looks like a table wherein the key should be unique. So it looks like a table. This is called the map, where you have the key and a value. K for key and V for value. Okay. The uniqueness here is for the key, not for the value. The key should be unique. And it is like an index, like an array. In an array, you have an index, right? So if it is a set of elements in the array, X, Y, Z, the index you have 0, 1, 2, right? So index is unique and it gives you the location. Similarly, here we have the key, but it is not numbers. It's not necessarily numbers 0, 1, 2. It can be numbers, or it can be names, or it can be any other thing. Like say for example, if you want to have a table of username and password, username XYZ, password 123, like this. Fine. So here we can use the maps. Here we can use the maps as a key value pair. Yeah, you cannot have two keys with the same name. Keys should be unique. The key values should be unique. So as I told, it is in a form of table, right? Here you have the key and here you have the value. So this key should be unique, not the values. Values can be repeated, but the key should be unique. Okay. So maps are dynamic in size, indexed by keys, do not allow duplicate values. The keys do not allow the duplicate values, and it is an unordered set of elements. There will not be any order, fine, for the map. So the map you can look in this figure, in these two figures, figure A and figure B, how the map looks like. Okay, you have the key here. This is the key values. Okay, and these are the values. The key and its corresponding elements. For example, let's say this is a search key and its value is this. So every key has an associated value. It's like an associative array. If you have studied like associative arrays in Python, in PHP, so there you find this associative arrays, which is almost similar to like that. But here the key will not have the duplicate values. Okay, so key can be taken as an index. Fine. Okay, map is an interface. Okay, it's an collection interface. Of course, it has these sub interfaces: sorted map, navigated map. It has an abstract class, abstract map. The concrete classes what we are going to use for the map is this tree map, hash map, linked hash map. Like for the set, we have what? Hash set, linked hash set, and a tree set, right? The same thing here: tree map, hash map, and linked hash map. In the set, we have the hash set, which is an unordered set of elements with no duplicates. Here also hash map, we have unordered set of elements with no duplicates. So here the keys will be no duplicate and it is in unordered set. Linked hash set is like linked hash map is like the linked hash set, which is what comes in the order. Okay, and a tree map is, of course, the key will be in the ascending order. The key will be in the ascending order. So we have three concrete classes for the map, like we have three concrete classes for this set: tree set, hash set, linked hash set. We have three concrete classes for the map: tree map, hash map, linked hash map. The map interface has the following methods. You can see clear will remove all the elements contains key. We'll check whether a particular key is in the map or not, and it returns true if the key is present, and if not present it returns false. Contains value, we'll check for a particular value, not the key, the value. As we said, like we have the keys and the values, right? This is the key and this is the value. So if you want to check a particular key, we can call this contains key for the keys and contains value for the values. Okay. Entry set, it returns a set. Map entry, return a set consisting of entries in this map. Get key, if you want to get a value for a particular key by knowing the key, you can get by using this get method. Okay, if there is an x key, so I can call get of x, will give you its corresponding value. Let's say 123 is the corresponding value. This will return 123. Okay, is empty, of course it will check whether it is an empty map or not. It returns true or false. Key set will return a set of key values, I mean the keys. If you want to return all the keys in a set, we can use this key set. Put here is a method to add an element to the map. To add an element to the map. Put is used to add an element to the map. Put all, if you want to put, add a map to an existing map. If you add, an existing map to another map, we can use this put all. Remove by knowing the key. If you want to remove the value, you can remove the key and the value by using this remove method. Size, of course, return you the number of entries in the map. Values will return you a collection of values. Like key set will return a set of keys. Values will return a collection of values in the map. Okay. So again, the same methods here in categories with its descriptions. Size, we are gonna use to know the size of the map. Put is gonna use to add a key and a value to the map. Get the value by knowing the key. Key set values will be getting the set of values and the set of keys. Remove a particular key value pair from the map if you want to remove by knowing the key. Is empty will check whether the map is empty or not. Contains key will check whether the key is present or not. It will return true or false. Contains value will check a particular value is present or not in the map. Returns true or false. Okay, so this is an map interface. Of course, the concrete classes we have in the map interface, as we saw before, we have the hash map, linked hash map, and a tree map to be used. Okay. There are three concrete classes that implement the map. Hash map, it is implemented as a hash table, and there is no ordering on keys or the values. Tree map is implemented based on red black tree structure, and it is ordered by key. It is ordered by key. Linked hash map inherits hash map, and it is implemented as a linked list. So the order of the key and the value will be according to the insertion order, like the linked hash set. Okay. So if you want to create a map, we can create it like how we create the sets. Fine. So very simple to create a map. As we create the sets, we can create the maps also. Just let me take this out, or let me just comment this one so that you'll have this program here. So let me create a map here. Map of, now here you need to mention two things. What is the key type and what is the value type? Okay, let's say for example key is an integer and value is a string. Fine. And the name of the map, for example, let's say that map 1 is equal to new hash map of integer of course integer as an key and a string as an value. Fine. So now map 1 is a map, okay, is a hash map where we can add the elements by using put method. Okay, so if you want to add an element to this map1 dot put of the integer value, for example, let's say that 2 and the string, let's say that it is Muhammad. Okay, now you can simply print the map and see how this goes. Print ln of map1. So you see the 2 and Muhammad. Fine. Let's print the size of it. System.out.println as map size. Map1 dot size. It is 1 because there is only one element. Okay. Okay, similarly you can mention the capacity, like if you want to initially mention the capacity, or similarly you can also, if you want to create a new map from an existing map, you can create it like what we have seen. If you want to have a sorted map, you can create a tree map. If you want to have a sorted map, you can create what? A tree map. Fine. Like for a sorted set, we use tree set, right? Similarly, we can create a sorted map here. Okay, you can traverse through the map by using the for each statement. Or simply you can print it. Fine. Okay, how to use that for each statement is that I use it here for. So basically what you need to do is that you need to get the key set. Okay, the key set will give you the set of all the keys that you take one by one and into a string. If it is a string object, I mean the keys are a string, then you take it in a string and you call that get of x, get of the key. Okay, because the get of the key method will return you what? The value for that particular key. Fine. So I'll use here for integer. Why integer? Because my keys are integers. Okay, integer x to map1 dot key set. Fine. Now this key set, map1 dot key set, will return the keys one by one to the x. Fine. Now after that I can just simply just print system.out.println of the x as the key value. So let me make it like clear here, key as x. Okay, and now the value, and the value as what? As the map1 dot get of the key value. Right. So this way I can print it. What is the problem? Expected. Here plus is expected here. Yeah. No, map1 dot get of x. Okay. Okay, now let's see that how it will print. This is by using for each. So I have a key to value Muhammad. This is by using for each. Okay. So let's say like map1 dot put of 3 and Ahmad, and map1 dot put of 4 integer and the value string value Abdullah. Fine, some values. Okay, and let us run this one and see. So you have here all. If you simply print this, it is like this, 2 equals Muhammad, 3 equals Ahmad, fine. But if you print this by using for each loop, you can print it in your format how you want, okay, in a form of table or in a form of more like values, okay. It is all depends on you how you want to make it or how you want to format it, okay. Now here is an exercise. Create a hash map that maps the name to their ages. Here we have the name and the ages. Now here what can be the key and what can be the value? The program first create a hash map with the name and its keys as its keys and the age as its values. So here we need to keep the key as a string and the value as integer, okay. Then display the contents. Then print out the names whose age are greater than or equal to 30. Print out the age of Louis, and the program then create a tree map from the hash map and display the mapping in ascending order of the key. Now let's do this one. What you need to do is just remember these names and their ages, okay. Let me just take this out here. The voice is cutting in between. Is it clear now? About other students? How about other students? The voice is clear to you all? Yeah, it seems have it clear here. I tested and it is clear. I think Asad, you are getting it clear right now. Yes, Asad, are you getting it okay? Sound? Okay, that's good. So let's create here. We are creating a hash map here. Map of name with their ages. So I'll create map of name is equal to new hash map of string for the name and the age integer, okay, integer, fine. So I create this hash map. Now I'm gonna add these elements to the hash map, okay. That is the name dot put of the first name is Smith and its value is 30, and then name dot put of Lewis and the value is 29, and name dot put of Anderson and the value is 31, and name dot put of what is the key, cook and the value is 29, fine. Now simply display these map values, okay. So I'll say system dot out dot println map values map is system dot out dot the name. There is a question here. Can key can be any data type? Yes, it depends on the question. And it can be integer, it can be string, it can be any other object type. No matter, and it can be of any type. So you see the map here, we added the map here, Smith, Lewis, Anderson and Cook, and you see that it is not in order because it is in hash map. Lewis, Smith, Cook and Anderson, it is not in order. Fine, so it is okay. The next is, if you want to get the age of Lewis, you want to get the age of Lewis. The next question here is that print the names whose print out the age of Lewis. If you want to get the age of Lewis, it's very simple, that you know the key. Okay, you know the key, so you can simply just call that get method, system.out.println age of Lewis is plus the name dot get of the LEWIS. This is the key, right? So you can simply get that if you know the key. The age of Lewis is 29. So here we have the Lewis 29. Okay. Now we have another question here. It says print out the names whose ages are greater than or equal to, what is it, 30. So here what we have to do is we have to go element by element. We have to go element by element. Hence we need to use a for each loop here. So for string, why I am using string here? Can someone say why I am using string here? Because the string values, the key values are of type string, right? The key values are of type string, so I am using the string here. Okay. Okay, I want to check the ages which are greater than or equal to 30, and I want to print that names and the ages. Okay, so I'll check if the map dot get of the x, I mean this will get you the age. Fine, this will get you the age is greater than or equal to 30. Fine, so I'll print their name and the age, that is the key and the value. System.out.println the key is of course x. Fine, and its value is what, the let's put it like this, name dot get of x. Fine, so this will get you all the names whose value is greater than 20. So we have the here Smith 30 and Anderson 31. So two entries whose age is greater than 30. Okay. Finally, the program creates a tree map from the hash map and display it in ascending order. Of course, very simple. We create a tree map here, map of a string comma integer of let's say tree name is equal to new tree map of string comma integer of what, of the name. Okay, and you just print this tree name, system.out.println of tree name. This will print you the map in ascending order of the key. Okay, so here you see that Anderson first, then Cook, then Lewis, then Smith. This is the tree map. Okay, ascending order of the key. Okay, so a simple program. Fine, just to practice the tree maps. Okay. Similarly, we have this another program, another exercise where we want to count the number of words and how many times a particular word comes in a text. Okay, here we have a good morning have a good class, have a good visit, have fun. So if you want to count how many times good, how many times morning, how many times have, how many times class, okay, this program will help you. This program, in this one, what we'll do is we'll create a map where we keep the key as a word and the value as a count, and the value as a count. So we'll put a map like this where we'll keep the key and the value. The key is the word, like for example, have, and the value is how many times have. Will have 3 times, like this. We have fun 1 time, like this. Okay, so it's a same program. Here you can see that where what we'll do is we first split the whole string. So this is the whole text. Okay, and we create a map here, of course string as key. So this map is created like this. It is a string and this is a integer, because here we store the words and here we store the numbers, number of counts. We are going to split this whole text by space or by any other character other than a word. Okay, now we'll convert all of them to the lower case so that we don't go into case sensitive. Okay, and wherever the key length is greater than 0, we check if it is in the map or not. The map has that key or not. If not, we are going to add that key. Okay, and 1. So initially we add good here and 1 here. Next, morning. There is no morning key here. So what we'll do is we add morning and 1. Okay, next time when you get the good here, what we'll do, it has the key, so it will just go to that key, increment the value and add that value. So that add value will be 2. Fine, and so on. It repeats like this. Okay, so this is a solution for it. You can just try this program back at home, and hope it is inshallah easy, and you will get it very easily. Fine, so you don't need anything. Then later you can come back to me if you want any help on this. Okay, there is some important note here. The collection framework has 2 rotate interfaces, that is collection and the map. Set, list, queue are sub interfaces from the collection interface. Distinguish between the collection interface and the collection classes that is used to do some operation on array list, such as reverse, sort, etc., as you studied in meeting 6. So there is some difference between these. You did not use collection interface method directly. What we use is the sub interface, that is a set, list and queue. Okay, wherein the collection class method are used using collection class to invoke the methods like sort, sorting the elements. If you want to sort the elements, you can directly use this collection method. We have seen that in meeting 6 where we are studying about the list. So this is all what we have in this meeting number 11. So we need to do some activities here. We need to do some programs here, some exercises here, what we have. Okay, so you can go through all the exercises which are discussed in this meeting, in the sets and the maps, and you can consider this as an important meeting for you in terms of to learn the things in Java, to improve your Java programming and its knowledge. And at the same time, it is also important for your exams, for your midterm exam. Sorry, there is no midterm. For your final exam, and for your learning process and all. Okay. So meanwhile, if you have any questions, please go ahead. Any questions on this? No, we don't have midterm exam. We don't have midterm exams. There will be, hopefully there will be two what do you say, two homeworks, I mean 2 TMAs. Fine, 1 TMA you already have, you may get another TMA instead of the midterm exam, and then you can face the final exam. Okay. Yeah, it is. It will be for all courses. توزيع الدرجات ممكن راح يكون يعني الأعمال السنة 50% والنهائي 50% حسب العادة. ولكن نشوف الواجب الثاني هل هيكون 30% أو أقل. فإذا الواجب الثاني هيكون الأقل ممكن الباقي يكون في النهائي. مثلا إننا الواجب الأول 20% والواجب الثاني ممكن يطلع 20%، فهيكون راح يكون الأعمال السنة 40% وال60% هيكون في النهائي. أوكي. طيب بالنسبة للتسليم الواجب الثاني ما ندري، لسه ما نزل الواجبات الثاني. ممكن لو نزل هنزل كمان الجدول التسليم كمان. أنا أتوقع إنه ممكن هيكون وقت محدد خلال يومين 3 يوم إلى أسبوع. أوكي. فيكون ممكن يعني كهذا، ممكن خلال أسبوع بعدين نسلم الواجب الثاني. الوزارة قالت إنه الفاينل هيكون 20. نعم، الوزارة تعليمات الوزارة إنه يكون أعمال السنة 80% وال20 في الفاينل في النهائي، ولكن فيها يعني بعض الجامعات الأهلية هم هناقش مع الوزارة ونشوف إن شاء الله كيف الوضع. هل هنا كمان هيكون نفس الشيء ولا هيكون يعني شيء متغير؟ ما ندري لسه، لأنه رسميا ما جانا شيء. أنا شفت حتى التعليمات أو إعلان وزارة إنه يكون 20% في النهائي وال80% في الميد ترم في الأعمال السنة. ولكن الجامعة العربية المفتوحة لسه ما قرر هيكون نفس الطريقة ولا هيكون شيء ثاني. ممكن هيكون طريقة ثانية، أو توزيع الدرجات ممكن هيكون بطريقة ثانية اللي يوافق الوزارة كمان. فالأمر هيكون بعدين كلها عن الوزارة. إذا الوزارة وافق على الخطة الجامعة ممكن يكون في الخطة الجامعة أو على خطة الوزارة، يعني ما ندري لسه. Yes, they also said like GPA will not count for this semester, but as I said before, again it depends on the university and the Ministry of Education, their discussion, and how they're gonna make it more clear for us. Okay, because every time we need to wait and see for the things how it will be from the university side. Okay, we cannot decide on any other news until we get officially from the university. Fine. So we will wait and we'll see the university decisions, and based on that we will act, inshallah.